Oh yeah, let's see what's going on here. Is my audio working? Oh yeah, what's up, everybody? Welcome to the Artists of Data Science Happy Hours. Hope everybody's doing good. The waiting room is popping off. What's up? It's been an amazing week over here at the Artists of Data Science. Released an awesome episode on Monday with Jeff Chrysler. Hopefully, you guys didn't get duped by Black Friday deals. Speaking of which, it is November 27th, Black Friday. And super happy to have all you guys here. Damn, the waiting room is popping off. This is awesome. How's everybody doing? All right, what's going on? We got so many people: Waylon, Giovanna, Ashit, Naresh. Man, so many people I can't see. What's going on here? All right, cool. Welcome everybody. Welcome back to another epic installment of the Artists of Data Science Happy Hour. We got Nicholas Lothar. Wow, this is amazing. Dave Langer is in the building as well. We got our buddy Padmaban, who is, it's like 3 a.m. in India, and this guy is here making it happen, getting after it, man. So I'll open the floor up to him first, but welcome everybody. Super happy to have you guys here. A lot of new faces, man. So this is really awesome to see. But yeah, man. Padmaban, how you doing?
How do you, Harpreet?
Hey.
Hi all. How are you doing?
Awesome, man.
Happy to see you all here.
Yeah, dude. Super excited to have you here as well, man.
Yes.
So it's 3:30 a.m. for you. I know you probably want to get to sleep. So I'm happy that you're doing what you got to do to get the help that you need. So I'm happy to assist you, man. What can I help you with?
Yes. So I mean, let's get started, and then maybe I'll start asking questions.
Yeah, for sure, man. That is okay too. Christian, what's up? Nicholas, dude, so good to see you, man.
Yeah, you as well. It's another great cast today. It looks like. I wondered if it would be a little sparser because of Thanksgiving, but I guess not. Everybody's here.
Everybody's on lockdown. Nobody's Black Friday shopping. It's all just online. So people are just chilling at home, man. Dave, how's it going? Nishant, Naresh, Shyam, Himashri, Chin, Adam, Jennifer, Sheridan, Joe Reese, Giovanna, of course, is here. Waylon's in the house. So yeah, man, floor is open to anybody who wants to ask a question. Whoever wants to take the floor, go for it. While that person is asking their question, if you just want to hold your place in line, just type, I have a question right there into the chat, and that'll secure your place in line. So Waylon, how's it going, man? I know Waylon was actually introduced to me by Maya Grossman. Maya sent.
Yeah, what's up? I talked to her for a little bit, and she recommended me to talk to you. And yeah, this like happy hour thing, like it looks great.
Yeah, man, definitely. So I'm happy to answer any questions if you got any. If not, then I want to see what's going on with Giovanna and Monica. And I thought Dave was here, David Langer. Yes, he is. Yeah, there he is. I'm sorry, there's just so many faces on my screen right now. We got Joe Reese here as well. So yeah, man, super excited to have you guys here. How's your holidays been?
Yeah, man, a lot of fun.
Yeah.
So, yeah.
Yeah, got down
getting outside, hiking. Yeah.
Got down on the Thanksgiving dinners and all that stuff. Right on, man.
Is that Ray that I see? Where'd he go? He was just on my screen. There he is, Ray
Giller. Oh, nice.
Hey, man, I've been following you for a few weeks now. Tableau is kind of how I got started in the data world. So I love to see the little tips and tricks you throw out there for Tableau. Appreciate your content.
Hey, thanks, man.
So Ray, where are you joining from, man? Where are you located?
I am in central Pennsylvania, in the U.S., not too far from Hershey. Everyone knows Hershey chocolate, so about 15 miles from there.
Nice, dude. Well, awesome. I'm glad you can join. It's super happy to have you here. I do see a question in the chat from Sheridan regarding getting started in data science and how my podcast got started. Super neat, everything. Well, awesome, man. Go ahead and unmute yourself, Sheridan, and you can just give us a little bit of background about yourself. Sheridan.
Yeah,
No?
sorry about that, guys.
All
I'm
good, man.
over here trying to get into my Uber and everything. Crazy day. So no, I'm currently a master's student at U Chicago, and I'm just trying to kind of supplement what I'm studying with some data science and hopefully combine that into being an awesome career. So like I said, I'm really new. I know I'm trying to get my feet wet, and I just really appreciate being in this space. And I just wanted to know if there's any support or welcoming you can offer.
If there's any support or what?
Just welcoming or any tips or advice of how I can kind of get started, and just any kind of just general overview.
Yeah, I mean, lots of tips and advice. That's a very, very big question to ask, but I'm just going to assume that since you're working on a master's in data science, you've probably been exposed to all of the foundational technical knowledge, all the tools, mathematics, stats, programming, and all that stuff, right? So you've been exposed to all the theory, you've gone to class, they've given you all the tools, but you probably don't have much experience really applying that, right? And
That sounds about right. Yeah.
all right, so you need to kind of bridge that gap, right? And there's always that cycle of you need to get experience, right? But you can create your own experience. You can create your own apprenticeship in data science if you've already learned the basics and the foundations. And the way you do that is by creating a really well thought out, well crafted project, right? And what I mean by well thought out, well crafted is that it's got to be more than just like the data sets that are present on sklearn data sets, those toy data sets, right? You've got to find a unique original project, not necessarily groundbreaking, earth-shattering, but just something that's in line with your interest and in line with, where you want to go with your career. So for example, if you're trying to get into e-commerce, maybe you want to do a project that's a recommendation system project or a churn prediction project or something like that. So that's the next step, I would say. I'd love to hear what Dave Langer or Monica or Giovanna has to contribute to that.
I guess I'll go ahead and go first. I think probably the single most important thing is create a functioning definition of what data science means to you in terms of what you want to do professionally. Unfortunately, if you're familiar with object-oriented programming, data science is now object. Everything is data science, ranging from creating dashboards to deep learning, computer vision for self-driving cars, all that kind of stuff. So if you're going to create a project portfolio, which is a really good idea, two things that are going to differentiate yourself. One, make sure that it's relevant to a business domain that you're interested in. Just generally speaking, a general classifier on Titanic, which I love, by the way, everybody knows I love that. That alone is not going to be enough, right? If you want to work in supply chain analytics, study that, build a project around that, or marketing, or whatever it might be. And also do research. Go to these big companies where you might want to work, look at their job postings, cross-reference the kinds of skills and activities that they're listing, and that kind of gives you a more general sense of what the jobs actually are. So for example, Facebook has a data scientist title, but if you look at the job descriptions, predominantly they look a lot like a technical data analyst at another company. So just be aware of all of that and plan appropriately, because you just can't say, hey, I study data science and I'm a data scientist. It doesn't really mean that much anymore, because things are a little bit more targeted based on what kind of company and what kind of role you want to work for.
But
I
Dave,
appreciate that. Thanks, guys.
Dave, how do I find out what problems are solving in those industries? How do I
Yes,
do
that's
research?
exactly what I was going to say, to go off of what Dave was talking about, the domain. So if you find the domain that you're interested, whether that's supply chain or the financial industry, health industry, figure out what kind of problems those industries are trying to solve and focus on solving that problem. So while you're working on the project, no matter what cool tools you're using or what technologies that you are working with, you just want to really hone in on what the problem that you're solving is and what that solution is.
And Google is your friend. If you Google supply chain analytics, you're going to get back an MIT course at edX that you can take, for example. That's a great way to actually learn about what the problem domain is and what kinds of tools and techniques they use. So Google it. Start with Google.
Get very comfortable using Google Advanced Search and do searches for white papers and PDFs. Giovanna, yeah, go for it.
Yeah, I love the things that have mentioned Dave and Monica. I would like to add just this word coherent. Be coherent with all your projects, and it's the essence of Monica and Dave. They have said that. Another idea, it could be if you want to be part of a company. For example, if you have in mind that I want to work for this company, or I love the philosophy or the vision of this company, of maybe not just one or maybe two or three, it's great to follow these companies on the website, on LinkedIn, and talk with, write to people, post, respond to the answer to the post that the company publish, and all these things helps, because the first thing that you know more about the culture, you know more about the project of the company, that if they call you for a interview, you know more about them. And another important thing is that you are in contact with people who is interested in this company too. And it's a way spotlight yourself with this company. So I think this is another way of knowing more about what is happening around that field that is very important. Because if you choose, for example, healthcare, you are knowing more about this field, and at the same time you are knowing more about what projects are doing these companies. You can give some ideas in answering this post, for example. This is something I could add.
Absolutely agree. I think a lot of the times when people are breaking into the field, they spend a significant portion of their time just focusing on the acquisition of technical skills without really exploring outside of that and seeing what the trends are in the industry. So if we wanted to go figure out how to get up on trends in the industry, Joe or Ray or Nicholas, how would we do that? What are you guys' go-to sources for that?
That's a good question. I sort of cheat in that I'm close to all types of customers and projects, usually in kind of bleeding edge stuff. So I think I have a pretty good idea of what's going on or what's coming, right? But I would say, meet people like myself too, if you want to get an idea of where things are going, at least, and I guess I have an awkward path, I think, versus a lot of people here, just because I was basically doing more data science. Now I think I'm more doing data architecture, data engineering, but I can get into that, the reasons why. But that said, the pace of change in data is, in terms of what's going on, new techniques, new technologies, accelerating every day, right? So it's sort of weird advice. On one hand, you definitely need to stay on top of stuff. On the other hand, there's a lot of noise. I would say like 90% of the stuff out there is noise. And it's just as important, I think, to stay on top of new advances as is continue mastering the basics. So what would the basics be? Dave Langer's courses, I think, provide a very good foundation. Analytics, things like SQL, things like, and if you're going to get in engineering, things like shell scripting and just things that aren't going to go away. Get good at that. And I think once you get good at the basics, you can circle back, and I think you have a better sense of how new technological advances are going to be, whether they're going to be important or not. So
I'd love to hear from either Nicholas or Ray. What do you guys think?
I think there's an interesting parallel, and hello everybody, guys. It feels like there's a lot of data rock stars in here. I'm kind of like starstruck at the minute, so that's good. Something that Joe touched upon about keeping on top of advancements in technology, I think there's an interesting parallel there. We talk about the business context and the business application, and that's actually keeping on top of business challenges. I spent quite a bit of my time in data being the schmoozer and the salesperson, and approaching people, essentially trying to get buy-in and trying to get money for some of our big data projects, and handing that over to people who are much more skilled in the data science part than I am. And I found some of the quickest way to get on side with people is to learn to speak the language of the people that you want to get on side on. So if you're interested in data science from the point of view of getting into marketing and you want to break into supply chain analytics or anything, learn to speak the language of the decision makers in that area is so important, because you want to be able to speak not in terms of your model, not just in terms of I've built this great model, you know, and it's X and it's Y and Z, but speaking, you know, what things are they interested in? Customer churn, revenue. Like, it sounds simple, but it's a great way to build trust. And keeping on top of challenges that within the organizations that you work within is pretty important.
Yeah, building a repository of that key terms and vocabulary, so you got these ideas of what it is that they're talking about in the industry. Sorry, I cut somebody off.
No, I was going to add too, I think some of the more interesting people that I've hired, I would say some of the more successful ones have been those that are kind of zigging while other people are zagging, right? So I would say it's, if you can, like, one of the best hires I ever made was this 19-year-old college dropout who sent me a resume, and he shows up into my office with the combat boots, nose ring, looking, I don't know if he was looking to rob me or looking to get a job or something, but in either case, you know, it's a bit of an unusual approach. I was like, he's here, let's do a quick interview. And he blew me away. His technical competence, his ability to communicate, I think were better than a lot of the senior engineers that I'd hired. At which point I was like, well, you have a job. When can you start? And the thing that really caught my attention was his passion around engineering and cryptography, right? Like he was doing that in his spare time since I think like the age of 12 or something crazy. But you know, he demonstrated passion in something he was interested in and was able to speak maybe not terms that I was familiar with, but I could tell like this is something that he was really passionate about and took a lot of interest in. And I also say, like, if you can find projects that are interesting to you and really dive into those and publicize those, I think that really goes a long way. Don't do like the, you know, people, there's definitely advice against doing like the CAN standard projects like the Titanic or whatever. I mean, it's been done a million times. If you can find something that's like interesting to you, you're also going to learn all the latest techniques and everything you need to learn to solve that problem just because you want to solve it. I think that might be one of the better ways to approach if you're just starting from scratch, because at least you have a vested interest in something and you're not being force fed, you know, a bunch of information that the technology, if you're trying to learn technology, the thing is, if you aren't applying it, you're going to forget about it. So
one more thing I would add, just to build on top of my good buddy Joe here, is the technical virtuosity aspect of your project is just basically table stakes these days. Everyone's got a deep neural network, everyone's got a XGBoost tree, you know, whatever. Where you can really shine is in your communication. Make sure that your code is well written and well commented and your variable names are nice, and make sure that you have great finely crafted like verbiage around your project on your GitHub pages. Maybe create a YouTube video with your face in it like this and recording it, and use your verbal communication skills. Wrap that all up, because a hiring manager, if they look at it, is going to say, somebody who knows how to do deep neural networks these days is kind of dime a dozen, but somebody that can do that and communicate well.
Speaking of skills that never go away, communication, empathy, problem solving, problem finding, and critical thinking. Oh my God, Greg Coquillo in the house, man. Good to see you again, Greg. Good to see you again, my friend. Happy to have you here.
Hey guys.
Hey man.
What's up?
Good to see you, man. Let's move on to Melania. I think Melania just said first time here, excited. Well, I'm excited to have you, Melania. I don't know where you are on my screen, but oh, there you are. How are you doing?
Hi, how are you?
I'm good, thank you. Well, you've
Great.
got a ton of people here who can help you with any advice you need related to data science. So go ahead and ask away.
Sure. It's my first time, and I was communicating with you through the LinkedIn, which I really appreciate. You mentioned it's going to be, Central Time, so I was able to sneak away from my position from a job. So, yeah, I'm Melania. I am a bioinformatician or a big picture data scientist, and I self-trained myself, and I am in academia currently. But I'm interested in moving away because I think now I'm ready to move and then join industry. So my main understanding is there are a lot of opportunities in industry, but just because I'm coming from academia, I am not sure the best way that I can represent that I am ready to get into the positions. I'm here to learn from your expertise and knowing how you transition away from academia. Because I self-train myself, so that means that I do not have that many resources in academia to help me get out. But yeah, I would love to learn from anyone and everyone and to observe. Thank you.
Oh, right on, man. Thank you for coming and thank you for asking your question. So did you say you are a biostatistician right now? Is that what you said?
Bioinformatician, yes.
Okay, yeah. So I used to be a biostatistician once upon a time. So it was a very similar transition for me. I mean, it wasn't academia, but it was a very research-oriented, research-focused role, right? So very academic in that sense. And I think the biggest thing for me to the gap that I had to bridge was understanding how business people think, and as well as understanding how to write decent software. So that was like the two big gaps. I'm guessing you probably use a whole lot of SAS right now or a whole lot of R.
Yes, R.
Yeah. So in terms of translating your experience with the R from academics to industry, I would probably toss that over to Dave. But Thom as well. I did not see Thom there. Yes, Thom is here. Thom's also a academic as well as Dr. Thom in the house. So yeah, I'd love to hear what advice either one of you guys have for her.
Oh, shoot. I really don't know much about SAS and R. I always defer to my buddy Dave on that too, or Danny Ma. But if you can use it in production, it's a great tool.
Thom has gone mute.
Oh, I think he's done.
Yeah, go for it, Dave. So let me try to rephrase the question. So Melania says she has some experience in R, but in an academic setting, and now is trying to bridge the gap from academia to the business world where data science is primarily played. So what challenges do you see somebody facing coming from an academic background that primarily uses R in that research setting to somebody who's going to be using it in a business type of role?
Yeah, and just so that we're clear, I've never been in academia, only in the commercial realm. So keep that in the back of your mind. I would think, based on my experience, probably the single biggest thing to decide, once again, and I know I sound like a broken record, is where do you want to work? What kind of role do you want? Because Thom mentioned one of my favorite buzzwords that just gets me just going, which is production. If you want to write and build and maintain production machine learning pipelines, generally speaking, you're going to need to get off R and get on Python. That's just the expectation in the job market. Rightly or wrongly, that's just the way it is. So that's the first thing you have to decide is, do you want to stick with R? Do you want to find roles that in the market are conducive to an R background, which there are many, many, by the way. Don't believe the total Python hype. There are plenty of jobs out there where they'll say, oh, you know how to do this in R? Okay, no problem. But as I said before, if you want to do production computer vision with automated cars, you're going to need to learn Python. That's just the way it goes. So if you want to move into academia, move out of academia in the industry. That's the first thing you need to decide. Do research. Look at the companies. Look at the jobs. For example, I've looked at 70-something job descriptions from Amazon and Facebook, and they're all basically, look, if you got R or Python, it doesn't really matter. Can you actually do the work? And most of the skills are relatively, I don't want to use the word rudimentary because that's so derogatory, but relatively simple in a good way. So do you know a data viz tool? If you don't have a data viz tool, pick up Tableau or Power BI. Probably Tableau because that's the dominant tool, but it doesn't have to be. Power BI works just as well. Learn how to visualize data, match that with your basic statistics or even more advanced statistics, and then R, and then say, okay, this is my bundled skill set. These are the things I can do. And then go map that to jobs in various companies. And then you can say, where's my fit gap? And generally speaking, you might be surprised that, for example, and Greg could probably attest to this at Amazon, for example, if you want to get a data analyst position at Amazon, if you have R, if you got data visualization, if you got statistics, and if you can speak reasonably well the language of the business, you're probably going to be a pretty powerful candidate.
Speaking of getting a job at Amazon, LinkedIn Top Voice 2020, Greg Cockier is actually an employee of Amazon. So what does somebody need to do to get a job at Amazon, Greg?
That's a cool question. I think Amazon should be put in the basket of any other company looking for talent. One thing I'd like to say is I like to tell people is, let's start demystifying companies like Google, Amazon, and understanding that we are the talents that are driving their success. So there's really nothing special. If you think about any company that produces a product, a service, they will come up with different problems to solve. And depends on what your skills are, you will find an opening, a job position that best fit your skills. I wanted to say something to Melania about academia. One thing I wanted to say is, I think before you made that jump, and Dave made a very great point, I think if you start from the end, meaning where you want to be, what kind of problems you want to solve from a business problem statement, then work backwards to figure out what are the tools and skill set you need to use to solve these business problems. So in academia, you are deep diving into the theoretical realm, which is a very strong point. And if you can start building those bridges between all of this theoretical knowledge with real life problems these companies are going through, if you zone in on the ones that are of high interest, then you can work backwards to figure out what are the tools, including the ones that Dave were talking about. So when it comes to Amazon, finding a job there, what are your skills? Trying to do some research about what are the problems this company is going through. And then these companies they're also good at giving you how to prepare for the interview. So they have the 14 leadership principles for Amazon. They have the STAR method. I use the STAR method to redo my resume. I prepared the 14 leadership principles. I also trained, did some mock interviews, recorded myself, listened to myself respond to the questions in the STAR method, and then readjusted. That's pretty much it. There's no mystery to it.
And I also want to say that, don't think that the experience that you've had as a biostatistician or bioinformatician is like gone to waste. Like you've got a skill set that is going to be extremely valuable in industry as well. I mean, I didn't know how valuable writing hundreds and hundreds of statistical analysis plans were going to be until I realized that people in industry don't document shit that well, and I have to get stuff in order, and so that became a very handy skill set to have. So let's keep it moving. Melania, if you got any other questions, just feel free to let us know. Somebody here is asking if it's necessary to get a master's to have a good job as a data scientist. It looks like there's a ton of discussion about that. I'm willing to say that the answer is no. Is there a consensus among that? Monica, what do you think? Giovanna, what do you think? Do you need, I have a master's degree in math and statistics, so I might be biased, but you don't need one.
Was the question a master's in data science?
Yeah, who asked?
That didn't exist when I was in college. I'm sure that didn't exist for a lot of others.
Yeah.
So that's something very new. But if you do have, to your point, a master's in mathematics, statistics, maybe computer science, something quantitative that's transferable, I think that would be beneficial as well. Or even in another area that's not technically math related, but you can have that communication skills and writing skills that are transferable as well, and kind of learn the math. I think it would be more beneficial to have at least something math related though.
Yeah.
I think the question was more like, is it necessary to do a master's to have a good job as a data scientist? So it could be any master's, but then as we were talking about earlier, Dave pointed out correctly that data science is sort of this overloaded term at this point. So you're dealing with like a master's degree in an overloaded field. And so I would say just pick something you're interested in doing. I don't know. I mean,
yeah. I mean, I could.
If you want to go work at OpenAI, for example, you probably need a PhD, right? Because you're being an AI researcher.
Yeah.
And I was talking to some guy at OpenAI last week about this, and it's like it's interesting all the different perspectives on data science and AI right now. Like you get people who are working on GPT-3, but that's not the same thing you're going to be working at like an insurance company.
Yeah, so there's like really data science is like an entire ecosystem made up of a bunch of different roles, right? You've got your traditional data scientist role, you got your data analyst role, you got your data engineer, you got your machine learning engineer, and then you've got like a research scientist type of role. Any role that involves heavy research, I'm willing to bet that you will need to have graduate training, graduate education in that. All these other roles are really practitioners. You're a methodologist, you're applying a certain tool to a certain problem. Do you need a master's to do that? No. Do you need to know your shit? Absolutely. You need to know how to do the job in order to have a good career, because otherwise you'll end up getting fired. So you need a solid set of skills that you can demonstrate and just perform well on your job, and then you'll have a good job. But I wouldn't say that. Yeah. Go
Dave,
ahead.
correct me if I'm wrong. I don't know if you've researched that before. So at Amazon, a research scientist, typically they fetch for a PhD level person. This is because they are focusing on things that haven't been solved before. So they are heavily trained on statistical analysis and knowing how to test and retest and readjust. And then you have the applied scientists that are either PhD level or a master's level, because they do have a very sound, education on statistics. So I don't know if you've ever researched that, Dave, but that's what I'm seeing on the Amazon side.
Yeah, that's pretty common in all the FANG plus M companies that I've looked at. Generally speaking, if scientist is in the title, PhD is usually required. Sometimes you might see like masters with like 10, 15 years of experience, but generally speaking, it's a PhD. Once again, it really boils down to like what gets you excited? What do you want to do every day? That really allows you to choose your own adventure in terms of your investments. Me personally, I used to like geeking out, right? I was like slide the pizza under the door in the middle of the night while I'm cutting code when I was a software engineer. That used to be me. These days, what I really like doing is I like looking at data and then trying to influence the direction of the company or the organization based on the insights. And to be honest, you don't really need that much advanced stuff to do that. You really don't.
And you don't
Probably
want
the hardest thing is the communication skills usually.
And you don't want to live a life where you're just trying to meet spec on a sheet of paper, right? So don't worry about meeting specifications as required in a job description. Just do the work, get the experience hands-on, whether it's a personal project, whether it is working on the job, and focus more on developing the skills, developing the right mindset to think through a problem. That's critical thinking. That is realizing that you're going to need to employ the scientific method in some manifestation of itself to solve business problems. So focus on acquiring tangible skills rather than meeting specs on a.
I totally agree with this. Like, let's talk about like the cruel fate of irony in the universe. I don't even have a master's degree and I teach graduate school.
Yeah, I mean,
I teach analytics to data scientists, right? So it's like, and this is something I tell my students a lot. Is exactly your point. It's like you can meet all this checklist. I can make an arbitrary checklist for a data scientist, and you can try and make that. That's not going to make you a good data scientist, though. It's just going to mean you're good at like checking whatever hoop I just set in front of you. Like I said, pick something interesting, right? At the end of the day, you want to find work that you like and that you love. I mean, you got a long career ahead of you, and there's nothing worse than seeing people who have been stuck in careers that they just really hate doing.
I think there's two prongs to that question as well, because as we've touched upon already, if the question is, do I need a master's to signal to recruiters that I'm equipped technically to tackle the kinds of problems that I'll be engaged with? Well, what we've already alluded to is probably not, because if you can build a portfolio of projects, you're demonstrating that you have that ability. So it's not a little piece of paper that says you have a master's in data science, but you have a portfolio that shows you've taken a problem to a solution and you've had some kind of impact. So if you're looking at it from, do I need a master's to signal that I have experience to recruiters? Then the answer is probably not, apart from some of the more specialized roles we've spoken about. So then the question then becomes, do I need a master's to learn the technical skills that I would need to engage with the job? And the answer to that is, in data science, probably not, because there are a wealth of brilliant resources out there that you can tap into, whether that's mathematics, statistics, programming, like it's at your fingertips. So I think when you unpack it in that way, I'm in the camp of you don't need a master's.
Yeah, you don't need a degree in the thing that you want to learn to be good at it, right? I'd like to hear Ray's perspective on this as well, because I haven't heard much from him. But yeah, Ray, if you want to chime in, definitely go for it. And then
Great. So just to be clear, I am not a data scientist, so I'm here as a listener, but I have a lot of experience in data viz and just databases and stuff in general. So basically I'm trying to live out exactly what you guys are talking about. So the reason I'm trying to learn this stuff is I want to solve more problems, right? I want to be able to have that influence that Dave is talking about and other people. So, I'm not at this point pursuing a master's because I have the data viz, I have the data wrangling, and I have all, some of these, a lot of the major elements that go into it, but not the fluency in R or the algorithm. So I'm trying to build that out. And I know since that's already my career, right, I'll be given an opportunity, or I can even do it on the side, but I have access to good data to do it with and things like that within my company. So I can kind of build out there, and that's what I'm hoping to do.
I love it, man. Absolutely love it. Let's see what other questions we got in here. So Christian has a question. What resources did I use to get up to speed on the business side when I switched over? Just read a lot of books. So biggest one for me was Lean Analytics by Alistair Krall and Benjamin Yaskovitz. By the way, you can listen to my interview with Alistair Krall on my podcast. There's another book called Data Science for Business. Those are like the two biggest ones. And then just reading, like you go to any major company's blog or any major player in that particular industry, and you go to their blog and just research like data or analytics or machine learning, you'll get introduced to a whole host of like blog posts talking about the type of stuff that they're working on. And that just serves to build your vocabulary. You then understand, okay, this is how they're using this thing in this way. So that's how I would do that. I just want to take a minute real quick to shout out Ayush. Nice to see you, man. I know it's super late for you in India, or early, depending on, I don't know what your schedule's like. There's also Jacqueline. Yeah, man. Jacqueline, if you got a question, please go for it.
Yeah, so thank you. Just first, I want to say, Harpreet, thank you for organizing this.
It's my pleasure.
So I'm trying to start in the field, and I'm sure it'll be super helpful for me. So a bit like Melania, I just finished a master's in mathematics, and now I'm trying to do this bridge between my theoretical knowledge and like a more in a business setting. So maybe like I've seen a lot of bootcamps going around. My first question would be like, do you guys think it's necessary maybe to do a bootcamp to jump from academia?
Did you say you have a master's in mathematics?
Yes, but it's more in the theoretical, very like pure side of it.
Yeah. So I mean, do you need a boot camp? Probably not. You can easily pick up any book, whether it's Introduction to Machine Learning with Python or Hands-on Machine Learning with Python and TensorFlow, and work your way through that book, because simultaneously you'll get exposed to the scikit-learn API, TensorFlow API, Pandas API, right? The programming languages that you'll need. And you also get a high-level overview and understanding of how some of the commonly used machine learning algorithms actually work and are applied to solve particular problems. But if you do want to take boot camps, do recommend Dave's. It's a good one. But boot camps, no, I would focus because how much knowledge do you want to cram in your head, right? Like at some point you have to use your hands and have to be tangible, right? Like I can like watch somebody build a house. This has happened before. I've been on Habitat for Humanity house builds and I sucked at it. I would never trust me building a house. Just because I know how to hold a hammer and that I'm supposed to take the hammer and nail it doesn't mean that when I go do it for the first time, I'm not going to smash my finger against the wall, right? Like, you have to practice. You have to develop that skill, right? So take your theoretical knowledge and find ways to apply it. And again, I'm going to sound like a broken record here, but it's all about projects, all about practical knowledge. I'll let somebody else chime in as well. Actually, my wife said it's annoying because I keep saying chime in. So Romy, I know you're listening because she listens to this all the time. I'm sorry, I keep saying chime in. I'll let somebody else contribute.
I get asked this question quite a bit, usually via direct message on LinkedIn. And in all of my career, and I've been in the field for 20 something years now, so quite a long time. One of the things that you're going to need to study first, I would recommend, is applied computer science. You got to write code. You got to learn how to write code. And I would start with SQL. It is the lingua franca of data. You can't go wrong, and it's not wasted time. If it's the first programming language that you're learning, that's great. It's awesome. SQL is immensely useful. It's very approachable. I don't know what your math background is, but if you have any set theory, it'll be really easy for you to pick it up and understand the basics of working with sets in SQL, and then move on to there and pick Python or R after you've done some research on what kind of jobs and which kind of companies you want to work for.
So I'm actually trying to learn SQL right now. Do you have like any advice on which resources would be good for
SQL queries for mere mortals? That's a good one. Or Dave's course on SQL. That's another good one. So yes,
Can you
Dave.
type it? Yeah.
Yeah, Dave. Do you want to type in the link to your course? And I think it's Black Friday, so you might even get a discount if you sign up for Dave's course. But yeah, that's
the
Dave's
SQL
course.
stuff is free, by the way. It's on YouTube. I'll put the playlist in the chat.
Oh, right on. There you go. Yeah, so that's good. And another book that I always recommend my mentees is SQL Queries for Mere Mortals. I forgot who wrote it. It's John's with a V, John V something. I'll type it in the chat as soon as I get a chance. Or I can just send you the link on LinkedIn for it. Somebody just entered. Mark, what up? How's it going? Himashri, how's it going? Jennifer, how's it going? Sorry, Chin. If you guys, Adam, Shine, if you guys have questions, let me know. Anybody who doesn't have their camera on, they turn in like a black box, and I just automatically ignore them. So I'm sorry. If you guys have questions, just feel free to unmute yourself and go for it.
Yes.
I actually have a. Oh, go ahead.
I was just going to add to Jacqueline, if you wanted like a short tutorial, like kind of like Sandbox, W3 Schools is a good resource that I go to, and I can write that in the chat box too.
Harpreet, just a quick add-in to all these kind of questions. Let's just say you're learning something new or you're reviewing something old. Minimum 3 references handy. You get stuck, it really helps to read it from multiple perspectives. And like Harpreet's been harping on in a good way, dive into the concepts. Each time you have to go review something, use it again, try to understand the concepts. Every chance I get to speak to my business buddies, I remind them, guys, all machine learning problems are math problems. 80% of my work is turning our data into numbers and making sure it's formatted well. And you get good at that. You get good at really connecting those concepts to the problem you're solving. It's not that it gets easy, it just gets easier when you begin to think that way about each new project.
It's great advice, Tom. Thank you. So let's see, Jennifer, if you have a question, I'm just going to start calling people's names just to make sure that nobody's left unanswered. But Jennifer, you've been sitting nice and quietly for a while. If you got a question, feel free to unmute yourself and go for it.
So I do. I am very fortunate that I work at a large company. We have lots of databases, a disturbing number of databases. So I'd like to get my management bought into automating data integration and consistent dashboards. do you have any specific suggestions for what goes into the elevator pitch to management?
Ooh.
Nicholas already answered this, guys. It's beautiful. I think he and I are of the same opinion here. You take those people out to coffee or whatever, something social, you get to know them. You find out what are your fears and how can I bring data to your rescue? And you get good at doing that. I don't mean this meanly, but people that insist you have to have good business acumen to be a good data scientist, I think that's barking up the wrong tree. You go and talk to your business counterparts like you have business acumen equal to them, they're going to shut you down. Have a spirit of, I'm here to learn what your needs are. Let me just bring a little bit of data to help, and then do it in really small bits. Like just, hey, I dug up this data and came up with this bar graph. Is this moving the right direction? Then over time, you can move to some automated, beautiful dashboard, but start small, make friends. And Nicholas already really said that above in the chat, so I wanted to give him credit for that.
Thank you very much, Tom.
So I don't know if how many people know this, but I self-describe myself as a recovering enterprise architect. So this kind of thing used to be what I did for a living, which is why I don't do it anymore, by the way. To give you some sense of scale, my last enterprise architecture project was to create an enterprise information model for all of Microsoft, which broke me, by the way. So what I would advise, Jennifer, is start small. If you're going to try and take an enterprise first big bang approach, more than likely you are, in my experience anyway, you are not going to be successful. That kind of stuff. The DAMA crowd, if you know what DAMA is, they haven't really made much progress in 2 decades for a reason. It's really, really tough to do what you're describing. So aim small. Try to find synergies where you can, ideally across organizations. If you can find 2 executives that are willing to cooperate for mutual benefit, and if you can get a win there, you can then use that to start rolling that snowball down the mountainside and get it bigger and bigger. So aim small, find 2 executives that are willing to work together, and start there. That's would be my advice. Hard-won, painful advice.
One thing I want to add quickly, Jennifer, is that yes, start small, but as you grow, document. Because one thing that I suffer from, like I always see companies do, they have multiple databases, multiple clusters, and poor documentation that ties these databases to business processes. So as you are establishing that synergy, as you're taking on those small use cases and growing, make sure to document it so the big picture will make sense and adoption will be seamless. So,
Jennifer, hopefully that answered your question.
It does. Thank you, guys.
Awesome. So let's see if Chin Yang, have you got a question? And Mark, I see you. I'll get to you if none of these other people have a question. Chin Yang, if you have a question, feel free to unmute yourself. If not, then I'll go over to Adam. So Adam, if you got a question, feel free to hop on the call.
Looks like Adam asked a question.
Oh, he did?
Oh,
right there in the chat. Okay. Have experience writing complex SQL queries, but not much with ETL and database design or administration. Are there any recommended resources specifically for that? I'm going to fling that over to Dave because he just talked about his life as a recovering database architect.
Yeah, so the first question would be OLTP or data warehousing, because there are two different information architectures completely. So if you're no, okay. So for example, I've built OLTP databases from the scratch way back in the day and spent a lot of time building data warehouses. So for example, if you're more interested in the analytics space, DW, how you build relational databases in an optimized way for conducting analytical queries and analytical processing, you want to look in the data warehousing realm. And the guy that you want to check out is a gentleman by the name of Ralph Kimball. I'll put some stuff in the chat. Ralph Kimball is the man. He is the originator of the dimensional model, and he talks a lot about how you not only structure the physical tables themselves in terms of being optimal for analytics, but also he talks about the nature of ETL. What does your pipelines look like? What does staging look like? And by the way, and I think Joe will back me up on this, don't think any of this stuff is old school and doesn't apply. It still does, even today. Even in the era of big data, most of the basics still apply.
Yeah, what I was going to add is I think I work basically full time as doing data engineering and data architecture at this point, right? So like all the pipelining and data, various places where you put your data. One of them is Druid. I work on a lot. That's more of like a real time data store. And I think that to add to what Dave was saying too, there's also right now I would say real time and event driven systems are becoming much more I would say used across industries. And I would highly suggest as well as you're looking at architectures, databases and pipelines, incorporate some sort of learning about real time into that. It's a rapidly evolving field, and there's I think it's where everything's heading. So, well, you're talking real time analytics or event driven systems or real time machine learning.
I second all of that. Kimball's dimensional modeling book is awesome. Mark,
it's, what is it? Data warehouse design, I think it was. Kimball's book.
Yeah.
Classic. Get it.
Yeah, I'll pop a link to Amazon here in the chat. I'm looking it up right now.
Mark?
Oh, another good book would be Designing Data Intensive Applications from Martin Kleppman. I'll put a link in that.
Awesome. Thank you.
Perfect. So I was taking notes because that's exactly another problem I'm working on right now. So that's perfect timing. Another question I have is I just got put on last week a really cool text analytics project at my company to kind of expand our product to include that for our surveys. And one interesting kind of twist that I wasn't aware of, which is there's two components. Is one, what's like an optimal way, and keep in mind it's a V1, so it's gonna be really simple, optimal way to flag kind of bad comments. So, maybe employees like trashing their manager or saying things that are inappropriate, right? You don't want to flag those and bring those to the top of the rank for their employer to see. And then the other option is we have international clients. So we have different languages we're working on. And so like, how do you kind of take into account both, bad context and then also different languages for text analytics?
Do you have labeled data at all, or is this all just unlabeled?
It's all unlabeled. It's all unlabeled.
Do you have resources like a budget to use an external API?
No. So I think the way that they're thinking for this V1 is essentially just doing word counts and whatchamacallit, and regex just as a V1. They're not expecting some fancy model. It's more so to do a proof of concept to like prove like, all right, this is worthwhile to go into the machine learning route and get that labeled data.
Do you have specific words you're looking for to immediately classify a sentence or document as negative or bad? And if anybody else has anything to chime in, definitely go for it.
Yeah. So to give an idea, the company I work at, we work with employee HR kind of data. And so we have Glassdoor reviews that we pulled, and then we have the Enron data set that has a labeled component as well that has similar language. That's kind of about it. And thankfully I'm not the only like data person on this team. The person leading this project is really well versed in NLP. And so she definitely has a way around it. But I have my meeting coming up next week and just trying to be more informed before I go in the conversation.
Yeah, this might be a little bit old school, but if you don't have labeled data, you could always mechanical Turk it.
Mm-hmm.
That is actually a strategy I've seen it successfully implemented before. You literally just go and outsource it to a bunch of human beings that know English, assuming English, or the language in question,
Mm-hmm.
and have them go through and label the data for you. And typically from, I don't know where you're located, Mark, I'm going to assume the United States, relatively speaking, it's inexpensive because you're typically using people in other countries that work at a lower rate relative to the prevailing wage in the US. And that's one way around it. Now, of course, unfortunately, you have to run it like a project because you have to like send out samples, validate how accurate those folks are. And if you find enough folks or a vendor that can help you, that is one way to start getting labeled data, and that helps out a lot.
Definitely.
It's kind of old school, but it still works.
Yeah. No, thankfully we have a whole bunch of like PhD psychologists on my team who are very familiar with MTurk. So I can definitely chat to them a little bit and see how they go about that. It's a great idea.
Is anybody else familiar with this type of problem statement that would like to contribute? I'm gonna leave the crickets as a no. But yeah, great question, Mark. Hopefully you got something out of that. If not, I'll circle back for sure. But I just want to take a second to make sure that either Himashri or Pushyami, if you guys got questions, definitely go for it. Feel free to unmute and take over. Christian has a question. Did somebody unmute themselves just now? Ashit, do you have a question?
I have a question. So being a data scientist, how much big data knowledge is required?
How much big data knowledge?
Yes.
I mean, that's a
I mean,
significant
being a
amount.
data scientist.
Yeah.
So should we not got to know, like, we need to know the big data, I mean, how does it work, or is it necessary or is not necessary?
So I'm assuming your question is which big data stacks should I know, and at which level of technical depth should I know those
Yes,
technology
yes.
stacks? I mean, just be familiar with them, right? And I think the thing about being a data scientist is your ability to be able to quickly come up to speed on any technology when you need it, right? So right now you might not have any need for any big data tech stacks or anything right now, right? That's cool. But you need to be able to quickly get up to speed on that when you need to use it, right? So I think the ability to be resourceful enough to quickly learn a skill is more important than just having it right off the stack. To what extent do you need to know it? I mean, what kind of company are you trying to work for, right? Like, where are you trying to go with your industry? Like, do you have any clue? Are you trying to work in as a data scientist working with IoT devices? Because shit, yeah, man, you need to know that stuff inside out. Or are you trying to be a data scientist working at maybe a marketing company? Maybe not as much, right? So it depends on where it is you're trying to go. So once you get clarity on that, yeah, it all depends on the industry that you're trying to go into. So get clarity on that, I'd say.
And
it
also
depends where you want to work too, all at once. No, I would say like back in the day, like in the late 2000s, early 2010s, I think it was a lot more important to know big data infrastructure, right? So that was in the days of like Hadoop, I think around like 2013, 2014, Spark, and so forth. Nowadays, though, when you interface with these systems, I think it's like less and less important to understand, especially if you're a data scientist, like how Spark works, right? Because all you're doing is you're basically going to be interfacing through Zeppelin or Jupyter anyway, and so it kind of doesn't matter. All it's going to do is just like spread your compute out across nodes and stuff. So back in my day when I was doing a lot of that kind of stuff, it was yeah, you had to know how the entire infrastructure worked. But thank Lord you don't have to do that anymore. Like that frees you up to, I think, know more important things. And especially nowadays with even more, I would say the more modern big data infrastructure is actually, it's not Spark anymore. I mean, everything's moving back to the data warehouse right now. You're talking cloud data warehouse in Amazon, that's going to be Redshift. You got Snowflake, and Google, it's BigQuery, and Azure, it's Synapse. I mean, everyone we see right now, and this is a lot of companies at this point, we work with all the companies I just mentioned, but it's like you're seeing basically a movement back to data warehouses for anything where you need to query data. And this includes the ability to use Python against these systems. So again, the amount of knowledge you need to have about backend infrastructure, I think, is declining actually, which again frees you up to focus more on what you theoretically might be good at, which is analytics or machine learning or something like that. So
what do you think is causing the shift back to the data warehouse? Is it because now we have a bunch of space?
So mainly the separation of storage and compute. I think that's the big driver right now. Storage has become so cheap. You don't need to spin up a Hadoop cluster anymore. Like the notion of spinning up an HDFS cluster and holding all your data, I think that's long gone. I was actually talking to a Hadoop engineer a couple of days ago about this. We had this running bet. Like I was like, yeah, I think in a couple of years we're gonna have like a talk about this. You're gonna start agreeing with me. And he's starting to agree. They're looking at moving off of the Hadoop system and Hive into Snowflake, just because there's less things to maintain. I mean, you can have a full-time job maintaining a Hadoop cluster, but that's like useful for basically no one these days if you can get away from it. So
yeah.
Or
Imagine. Sorry, go ahead, Greg.
Oh, sorry. Actually, you could do like me, right? Who's on the business side and who's also not a data scientist. Is no high level enough. I think if you focus on understanding how the data was collected, right? How the data was collected and why, how it's stored, prepared, pre-processed, from a data warehouse perspective, how it's distributed and how you can pull from that to perform some analytics, like Joe was saying. And then, what are the tools you have on hand to present the data as well. So a high level, know enough to be dangerous, and also learn as fast as you can when the business cases show up for themselves, as Arpit was saying earlier. So
principles.
That's actually a really good point. What I see a lot of trends going right now in the data tooling space is actually it's away from data processing and it's more towards data lineage, data governance, data quality. Right. So I think to Greg's point, if you're going to center on something, like if you have to know how Spark works, great. The number of companies I see using Spark is actually dropping every single day, to be honest. But the question that never goes away is like, where does this data come from? And is this data any good? Right? Because if the data is crap, then good luck. So
I don't think
so. There's a famous saying in computer science that goes along the lines of an extra layer of indirection solves every problem. And that's true in analytics because it is a technical pursuit. So you have to ask yourself, why, if they want me to be way low in the stack and know all this stuff, why do I need to know that? If my purpose is to analyze data, provide insights to drive the business forward, why do I need to know all this big data infrastructure stuff? That's what I'd be wondering.
Awesome. So hopefully that answers the question, Ashit. I think Christian had a question about the Bible for writing production quality code in Python, Hitchhiker's Guide to Python. That's what I used. And let's see if somebody had a question. Was it Bushyami or Badmanaban?
Yeah. So hi all. I mean, this is an amazing experience. This is my first time here. I mean, so thanks Harpreet for doing this, and you can call me Paddy. I mean, I know my name is little difficult to pronounce. So yeah, I mean, you can call me Paddy. You can call me Paddy. So my question is that, I mean, there can be enough emphasis on domain-based. Domain-based. I think domain-based projects. I mean, to learn data science. So I love solving sports problems. So I mean, I just want to predict what is the next pitch. I mean, is it a two seam or it's a slider? So in baseball. So so to kick on with things, I started working on. I mean, as you said, I started working on effect of momentum in sports. So I just want to know why a team goes for a 24-over run or a 10 or a 5-over run. Or I mean, that's amazing, right? I mean, you can't pull off certain big things here. So my question is, there are a lot of data sets around. So what I did is I tried to get certain data sets from Kaggle, and I started doing the statistics. I run the runs test to predict whether whether the wins are random or I mean something like that. But my question is that how do I choose the right data, and how do I choose? I mean, how there are multiple ways to solve this problem, and I mean, is there a so-called right way?
There's no one right way. There might be ways that make more sense than other ways, but fundamentally, I don't think there's a right answer to anything in data science. Why? Because we're just using our simplest comprehension of reality, which is these mathematical formulas, which are just ways to describe the natural world to solve problems. I don't want to get into philosophical debate here, but like I don't think mathematical statistics is real. They're just we invented them as a way for us to try to understand something. In general, there's never going to be a absolute right way to answer any data science question. That's just, I don't want to get into philosophy, my philosophical view on that, but that's just how I feel about that. But I would recommend Kenji's sports statistics YouTube channel. Maybe I can get him onto the to the show one day, but check out his sports analytics thing and definitely get some insight from there. In terms of where to find data, I'm pretty sure most sports records are available publicly. You might have to scrape the data yourself and source it yourself, but it is publicly available. So go to whichever league it is that you're interested in. I mean, I'm just going to assume it's cricket. Sorry, I don't mean to be racist. I mean to. I'm assuming it's cricket. But yeah, you can go to their website and whatever the National Cricket League and download all the data there or scrape the data. So yeah, so I saw a lot of funny looks and people, I told people that statistics and mathematics isn't real. Jacqueline, sorry.
Can I ask a question here for the professional data scientists, especially the big teams who put systems into production? So I'm on a, I guess, journey to raise awareness on, we see all the hype about, artificial intelligence, ML, and we want to replace this with automation. And one analysis, especially people like me, forget to do is the cost benefit analysis. And, yeah, I want to automate it, but it's as expensive as the manual process. So you're really not solving anything, kind of thing. If I'm on the business side, what do I need to look into inside of the production process to key in maybe a unit cost of that production to justify or reject that automation? So this is something I definitely want to raise awareness across program managers, product managers. Don't fall for the hype yet. Make sure you understand first, it's not a rule-based problem that you're going through. It takes more than a rule-based. Then it's repeated, prone to error, etc. So let's move to machine learning. Okay, now you move to machine learning. There's a system already in production. Is it worth it? Yes or no? So who can help me pinpoint where to look to kind of put a cost behind that automated implementation?
So there's got to be some setup cost, right? So you have your fixed cost, right? And then on top of your fixed cost, you can add whatever variable cost there is to actually do the actual work, right? So that can be some aggregate of whoever's going to be working on it times the number of man hours expected, right? So that is your input cost to making this thing automated. You can estimate that, great. Now let's think forward. How much time are we going to save by implementing this automation? All right, cool. So how many people are going to be using this automation? How many hours is it going to, let's think of it this way. If one person uses that automation, how many hours is it going to save that one person? On average, that one person whose time gets saved, how much is that one person's hour worth to the company? Multiply those two together, multiply that by 52 weeks in a year. That's how much that one person is saving in costs over the course of the year. Multiply that by the number of people using the automation, and now you've got a estimate for the amount of money you're saving the company. Now, the setup cost, the estimated setup cost, cost benefit analysis there. So that's how I would approach it. Love to hear what everybody else has to say.
So Greg, you're speaking my language, man. Okay, this is what I used to do for years, was coming up with IT projects, IT programs, and getting them sold and then delivered. So the good news is, in a very real way, building a ML-based production system from a cost perspective is no different than any other IT project, generally speaking. All the things that Harpreet talked about totally fit in. Here's one thing that I would very, very much recommend, though. Find a business executive that's willing to commit in writing to the cost benefits, whether it's a higher sales or lower costs, whatever the ROI is of the company. Make sure you've got a VP, a director, somebody on the hook that says, yes, if you build this, I will commit that this is the value that it's going to bring. Believe it or not, oftentimes that might kill your project right from the get-go because nobody wants to do that. So get that. If you get that, then you say, okay, cool. You can price out the infrastructure, working with the engineering teams, all that kind of stuff. The one gotcha that I've found in ML systems and I've been bit by this by myself, is accurately forecasting the cost of retraining the model periodically through the life cycle of the system. That's the hard part, to get someone to nail that down. And that actually tends to inflate the overall TCO, the total cost of ownership. And oftentimes ML-based systems, at least in my experience these days, often do not pencil out because of that. Because the benefit that someone's willing to commit to, once you start saying, look, the model needs to be investigated every quarter, every month, whatever it is, and possibly retrained, new features need to be engineered, all that kind of stuff. When you add that cost in, sometimes it doesn't pencil out. So that last bit is critical. If I'm going to refresh the model, how often, how much is it going to cost each time I refresh it?
I was actually writing about this morning. Because it was a notion of total cost of ownership, right? But there's also the notion, we come across the total opportunity cost of ownership, which is the notion that if you're going to make an investment in an initiative, whether it's ML and automation or whatever, there's obviously the total cost of ownership considerations, right? Your operational costs, whatever cap expenditures you need to put into it, right? And the ongoing operational burden of doing this. Nowadays, what I would say, one consideration you should really heavily think about is, especially when you're working with engineering teams, what is the preference of technologies the engineering team may have? Are they going to want to involve themselves in some standing up open source stuff, or do you want to use a managed system or proprietary? Because what you want to work out is like, do you have options in reversing this decision if you get stuck in it, right? Or are you stuck with this infrastructure now that you're going to be maintaining for 10 years plus, in which case it's not just the models that you have to worry about, it's also the underlying technology that you just built and inherited for yourself. And it's a really big thing because now you have a team dedicated to this. And if you don't have optionality, it's going to be really hard for you to switch to new projects because your team is stuck doing this. We see this all the time. I can't even tell you how many Hadoop systems we're trying to move people off of right now. They're like, oh, this is like the hot thing in 2010 or 2008 or whatever. Let's obviously get on this. Now they're like, dear God, how do we get off this thing? It seems expensive and it's creaky and it's falling apart. And their machine learning suffering and everything else is suffering. So it's like, you got to consider like, what's your out as well? Like, how can I reverse this decision or am I stuck here? So.
Yeah, so at the speed that I'm seeing this, these technologies are evolving, I'm assuming the more you have new technology come out, the more expensive it is to retrain a model throughout the production's life cycle. And, I'm assuming that future cost of retraining, is expensive, like Dave was saying, might inflate your TCO. And how do you, pinpoint that future cost? That's one thing that's in the gray area for me. So I do appreciate the insights here. So thank you for answering my question.
Thank you for asking, man. That's a great question. Question here from Himashri. Oh, man, I'm trying to get philosophical with it. I see this a lot. We need a good data scientist. What's the fine line between a data scientist and a good data? I can confidently say I spend 0% of my time thinking about how to be a good data scientist. I focus most of my time thinking about how I could be the best data scientist that I could possibly become. And that is just focusing on making sure that I learn more than I knew the day before, developing my craft, honing a sense of mastery for my craft. And actually, this is a common question I asked a lot of people on my podcast. A lot of the data science leaders, I'll ask them, what's the difference between a good data scientist and a great data scientist? So I would say, don't worry about how to be a good data scientist, worry about how to be a great data scientist. And I will open it up to whoever else wants to answer that question. Go for it.
I would like to say something that first, thank you, Harpreet, for these sessions because they're amazing. I'm learning a lot from all of you. And there are some takeaways, my takeaways, that I would like to share with you. The first thing is to have the capacity of learning fast and learning by doing. I think this is the thing that is very important if we want to become a good data scientist. Another thing is be creative and, oh my God, it's so sweet. Also, your baby. Is to be creative, to propose creative solutions. Because when you need to do some projects, for example, Jacqueline, that is starting to do that. And I want to tell you, Jacqueline, that I would like to have all the knowledge that you have. So your starting point is like top. So I'm sure that you're going to be an excellent data scientist.
Thank you. That's encouraging.
So there you have it. That's how you become a good data scientist. Sorry, I didn't mean to cut you on, Giovanna. Go for it. Go for it.
Yeah, just to finish this idea is another thing that I have noticed in the interviews is that when they ask, present yourself, talk about yourself, you are presenting data. You are presenting your own data. And this is the way they can see your communication skills, because if you are going to communicate the results of all your projects or all the dashboards or the things that you have produced with the data to the stakeholders, if you are not able to present yourself, how can you present the results? So it's very important the way that you present yourself, because they are, in that question, they are seeing a lot of information. And I think the key is how you present data, your own data, that you know everything about yourself, how you present a person who has to decide if you are the one for that team. So I think these are my ideas I wanted to share with you. Thank you.
What do you think? They want to hear what you have to say. He was quite talkative earlier. That's what he has to say about being a great data scientist. All right, guys. Well, we are over time. Thank you so much for coming out and hanging out, everyone. Apologize if did not get to your questions, but I'll be back here again next week, and I hope most of you guys will as well. Keep an eye out for the podcast. We got a really cool episode coming on Monday with Nir Bashan. He wrote The Creator's Mindset. Probably one of the top 10 books that I've read this year. So check that episode out. I really enjoyed it. And guys, have a good rest of the weekend and good kickoff to the holiday season. And I hope to see you guys next week. Take care, everyone.
Bye. Thank you.
Thanks, everyone. All right.
Bye-bye.
See y'all.
Bye.